Hello, my name is Samuel Mottier. I'm product manager at ETEL. Today, let's go closer to tool point performance together. So let me describe the equipment we have here. In the center of this equipment, we have a VULCANO2 platform. This is an X, Y, and theta motion system based on iron core, linear motors, and a gantry architecture. This type of architecture is perfectly fitted for high payload, long travels, and a high duty cycle. On top of the VULCANO2, we have a bridge with a camera, and we are moving a wafer with printed patterns on it. The goal will be to bring patterns in the field of view as fast as possible and as precisely as possible. Below the VULCANO2, we have this blue box here, the Quiet. Quiet is a 6 degrees of freedom, fully active isolation system. It's controlled by the same control architecture and the same control line as what is controlling the motion on top. This Quiet active isolation system has two missions. The first one is to cancel out the floor vibration or disturbances coming from nearby equipment. The second mission, it is to cancel out all the forces generated by the motion of this heavy mass here. Of course, it will shake the whole infrastructure, shake the camera, and reduce the precision. So let's try a first measurement. In this first measurement, we are acquiring patterns without active isolation system. We are just passive isolated. To get to the certain precision level we want, we basically need to wait some time at the end of the motion. That's not something we want to do. But that's the only way to let the time to the system to damp. I'm clearly feeling that this thing is now shaking and I need to wait before acquiring my picture. What I want to do, I want to move and acquire without any waiting time. So let's start the second recipe where the Quiet is fully active now. We can actually hear that now all the forces are sent back in the structure of the bench here. That's why we hear it, but here nothing is vibrating anymore. I'm currently acquiring picture in a more precise manner and in a much faster manner. We can clearly see on the graph that by using an active isolation system, I'm still much faster and much more precise than any waiting time I was implemented in the sequence previously. Another advantage of having a camera and having a way to measure at the tool point is that I can create a map. A correction map of my mechanical structure, correction map of my substrate. This I did before by acquiring some reference mark, and now I can show you how this can help in moving scanning, for example, application. So we are now scanning along a straight line without the mapping activated, and as you can see in the picture, we are not that straight. These are all the errors related to mechanical errors, the substrate map errors, and so on. All that I know upfront, so I have actually programmed that in the controller, and I can do the exact same thing with activating the mapping. In that case, we are clearly following a straight line. We are actually 15 times better in terms of straightness. And of course, we can now improve performance of the overall system and of the overall process. So these were just a few examples of the combination of this entire solution, starting from the control, the damping system, as well as the motion control, the motion system and the vision system. Whenever you face your next motion control challenge, contact us and we'll be happy to help.